Assalamualaikum warahmatullahi wabarakatuh. Good morning, class.
Waalaikumsalam warahmatullahi wabarakatuh.
Morning, Miss.
Morning, Miss.
Before we start to listen, let's pray according to your religion. Please the captain class to lead the prayer.
Okay, my friends. Before we study, let's pray begin. Finish.
Okay, how are you today?
I'm fine. Thank you.
I'm fine too, thank you. Okay, before starting today's lesson, let's say Basmalah together. Bismillahirrahmanirrahim. Okay, I will check your attention. Henar Stadewi,
Present, Miss.
Intan Puspitasari,
Present, ma'am.
Ayu Budi Cahyani,
Present, Miss.
Sekarani,
Present, Miss.
Irma Rahmatul Jannah,
Present, Miss.
okay. Because we are still in pandemic situation, always pay attention to healthy protocol. I hope all of you are always healthy and also excited for today's lesson. Okay, today we will learn about distance between a point to a line in three-dimensional. Our learning goals today are: first, student can identify facts on the distance between point to line. Second, student can describe the distance between point to line. Third, student can determine the distance between point to line. And the last, student can solve problems related to the geometry of space. And what are the benefits that we can take? The benefits of studying geometry for everyday life are: first, geometry touch a logical area where on the regard the meticulous of and careful. Two, geometry is taught for practical purpose, meaning that geometry is taught to support other science. And the last, after studying geometry, you will have broader knowledge to understand the beauty of the space the earth surrounds it. Okay, I will explain about the distance between point and a line. Distance between a point to a line. Definition of distance a point to a line. In this picture, we can see the line segment representing the distance from point A to line BF is AB because AB is perpendicular to BF. Next, the picture, we can see the line segment representing the distance of point A to the line H is the line AQ because AQ is perpendicular to CH. Next picture, the line segment representing the distance of point B to the line BH is the line BD because BD is perpendicular to BH. From this example, it can be concluded about the meaning of the distance between a point to a line is the point to line distance is the length of the segment drawn from the point perpendicular to the line segment. M is the distance from the point P to the line Q. From point P, a line M is drawn perpendicular to line Q. The line M intersects Q at O. Point O is the projection of point P at Q. So, the line of projection from point P to line Q is called the distance from point P to line Q. To determine the distance between a point to a line, we need now some concepts. The concepts used are: first, Pythagorean theorem. Pythagorean theorem deals with right angle. For example, we have a right triangle with angles A, B, and C. The side in front of A we name is side A. In front of angle B is side B, and in front of angle C is side C. Then we can find one side if the other two sides are known. For example, we found out from side C. The formula is C equals root A squared plus B squared. Next, we found out for side A. A equals root C squared minus B squared. And we found out for side B equals root C squared minus A squared. The second, the basic concept of trigonometry. The basic concept of trigonometry deals with angle. If sin alpha equals A over C, cos alpha equals B over C, and tan alpha equals A over B. Third, area of triangle. There is a triangle and a right angle in C. We want to find the distance from point C to line AB. So that is the height of the triangle. Then the area of triangle is 1/2 times AB times CD. And if we turn the triangle, then the base is CA and the height is BC, area of triangle is 1/2 times AC times BC, because these two triangles are the same triangle, so the area is the same. The area of the first triangle equals the area of the second triangle. So 1/2 times AB times CD equals 1/2 times AC times BC. So AB times CD equals AC times BC. So CD equals AC times BC over AB. Of the three previous concepts, it is always related to a right triangle. If one you know is any triangle, then we can use the position of triangle projection. There is any triangle There is any triangle ABC. The side in front of angle A is A, in front of angle B is B, and in front of angle C is C. A is projection against BC, then we get A accent. The length of A accent to C is P. Then the length of A accent to B is A minus P. And we can find the side of P using the position of the projection of triangle. And the formula is P squared equals A squared plus B squared minus 2 times A times B. And we will be able to conclude the height of the triangle using the Pythagorean theorem. Example: in cube ABCD EFGH, the egg length is 4 cm. Find the distance between point F and the shape diagonal of BH. Now BF equals 4, FH equals roots EF squared plus EH squared equals roots 4 squared plus 4 squared equals 4 roots 2, and BH equals root FH squared plus BF squared equals roots in the bracket 4 roots 2 squared plus 4 squared equals 4 root 3. The distance between point F and line BH is equal to line length DF. If the area of triangle BFH is now 1/2 BF times BH equals 1/2 BF times FH. So, BF equals BF times FH over BH. BF equals 4 times 4 root 2 over 4 root 3. So, BF equals 4/3 root 6 centimeters. Next, the side line of the ABCDEFGH cube is 12 centimeters. If P is the center of CB, then the distance from point P to line HB is, let O be the projection of point P to line AB. Line O is the middle of the AB line because CB equals BH. First, consider the right triangle BCP. It is known that BC equals 12 cm and CP equals 6 cm. So, using the diagram formula, we can BP equals root BC squared plus CP squared equals root 12 squared plus 6 squared equals root 144 plus 36 equals root 180. 180 equals 6 root 5 centimeter. AB is the diagonal of the face of the cube and space the side line equals 12 centimeter. Then AB equals 12 root 3. So BH equals 1/2 times 12 root 3 equals 6 root 3. Equals root 108 centimeters. Consider the right triangle DOP. The length of the OP is the distance from the point P to the AB line. Using the Pythagorean formula, we get OP equals root PP squared minus OP squared equals root 180 minus 108 equals root 72 equals 6 root 2 centimeter. So the distance of point P to line AB is 6 √2 centimeters. Okay, thank you. Any question?
No, Miss.
No, Miss. Mom.
Okay, so that you can understand this topic, I will give you a homework. I have uploaded in Google Classroom. So the conclusion of our material today is the distance of point to a line is the length of the line segment, the contact the point perpendicular to the line, and the cube with the length of the side A has the diagonal length of the side that is a root of 2, and the length of the diagonal of space is a root of 3. Sorry if there is an error in saying. Then we can end today's meeting by praying together. Please, the captain class to lead the prayer.
Okay, my friends. After we study, let's pray begin. Finish.
Okay, thank you. Say basmalah together.
Alhamdulillah.
Okay. Thank you for your attention. See you next week later. Keep healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Keep healthy too, Miss.
Thank you.
Thank you.